Hello, so in this video we're going to be looking at the chain rule. We use the chain rule when we're differentiating a function of a function. What that means is before we were able to differentiate powers of x, we had y equals x cubed, and now we haven't got straightforward just an x inside this bracket, we've got another function. So we've got x plus 2 here, or 3x squared minus 1. So it's not just a straightforward x cubed x to the power of 4. Now the chain rule says this here, that dy by dx is the same as dy by du times du by dx. And when you're doing this, you will have to put this together yourself sometimes. And you should see that if you cross cancel here, you go back to d being left with just dy by dx. So sometimes people find it difficult and get things the wrong way round, but just do that little check and just make sure that if you cross cancelled, you would end up with what you started with. I've got the chain rule written up here so we can remember it. Now when you first start doing these, you should just do them methodically and work through them steadily. At the end of this video I shall give another method, a faster method, and as you become better at doing them you probably can miss out a few steps. But to begin with, first let's u equal 2x plus 3. So whatever's in this bracket here becomes your u, and that would mean y equals u to the 4th, because all this has become u, so you get y equals u to the power of 4. Now work out all the different bits. So what do I need to know? I need to know dy by du. So where's my y and u term? That's this one here. And we multiply by the power, and then we take 1 from the power, and 4 take away 1 will give us 3. And then the other thing I need is the du by dx. So this is the one with u and x in, and that's why we use that one. So if you remember, if we have 2 times x, we just end up with 2. And if we have a constant when we differentiate it, that gives us 0. So you could put plus 0 here, but nobody's going to do that. There we go. Okay, so now we can use chain rule. So here's my chain rule. We put the bits in. So dy by du is this bit, 4u cubed. And du by dx is this bit, which is 2. So it's 2, and so we multiply it out, and we got 8u cubed. And now we can think, oh yes, we've done, let's go on to the next question. You haven't quite done, because our question didn't have u in it, and we've got u in our answer, so we just need to substitute back for u into here. See that u there, we need to get rid of it, and so we put the 2x plus 3 back in here. So we get dy by dx equals 8 times 2x plus 3 to the power of 3. Okay, a slightly harder example, but just a much of a muchness, just the same sort of thing. So you choose the bit inside here, so we've got y equals 3x squared plus 2 brackets all to the power of 5. So the bit inside the brackets is your u. And then if this was u, then you can see that your y equals u to the power of 5. So we've just substituted in there. We work out the bits, so we want dy by du, so we have a look which one's got y and u's in, that's that one. Using the rule for differentiation, we multiply by the power, and we take 1 from the power of 5, take away 1 gives me my 4. And then the du by dx is this bit, du by dx, and so we multiply by the power, so we get 2 times 3 will give me my 6. And then we take 1 from the power, 2 take away 1 will give me 1. So there's a little x there, x to the power of 1 there, but we don't put the 1 in. And then we have a constant, so I could write plus 0, but we don't do that, but just so you can see where that's gone. And now we just put it together. So we put the dy by du is this bit. So we put that in here. And the du by dx is the 6x, so we put it in here. And then we just multiply it out, and this time we've got this extra x here. Now when I'm actually writing it an x, I always do it like this so you can't get confused between times and your x. Sometimes when you're using this software, it gets hard to see what you're doing. Anyway, so we've got here, let's just make this a little bit bigger. There we go. We've got the answer is dy by dx equals 30x 3x squared plus 2 to the power of 4. Okay, so hopefully you can see where all those bits come from. So the first thing is decide what your u is going to be, and you'll use the thing inside here, and then your y will be once you've substituted for your u. And you differentiate the two things as the formula tells you to, dy by du and du by dx. And then you just put it back together, and you remember to substitute back for your u, because your u wasn't originally in the question. Now, I'm going to do this other way because that's actually the way I do it, and I think it's the way most people in the end do it. If this is the first time you're thinking about this, stop now and come back to this later. Okay? So, what do? I want to differentiate this. I look at it and I say, actually, I'm just going to pretend that in here, this is just x. I'm absolutely in denial that this is a difficult question. All I'm saying, okay, what would I do if it was x to the power of 5? Well, I would multiply by the 5, and then I'll take 1 from the 5 to give me 4. But the thing in the brackets wasn't just x. So, this is just rubbish. This is not my answer. This is rubbish. So what I have to do is then go back and say, okay, I've got that far, but what actually was in my bracket? So let's have a look at what's in my brackets. And we differentiate what's in the brackets. So the 3x squared is going to give me 6x. I multiply by the 2, 3 times 2 is 6, and 2 take away 1 is 1, so it gives me 6x. And by the chain rule, I multiply by the result of this differentiation. So I multiply by the 6x. So then I multiply it and I get the answer. So I would only write this thing down. So what I would do is, first of all, just write my bracket, be in denial, differentiate as if it's normal. So take my 5 in front and take 1 off, and then say, actually, but in my bracket, it isn't just x. And then you multiply by the differential of what's in the bracket. And then you multiply it out to get the same answer as before. Okay, I hope that's helpful.